finally, something you're going to be tasked with doing is using these equations with x squared, these quadratic equations, and this factoring skill to set up and solve some problems that occur outside of the walls of our classroom. Quadratics show up in a variety of places, from areas of plots of land to modeling the amount of money you would make from selling various products based on how many products you sell. There's many applications, and you're going to be seeing problems, a variety of those problems, over the course of this unit. Here's an example of one of them. In this situation, a farmer plants a rectangular pumpkin patch. Maybe this is like the wing pumpkin patch over off of Zeeb Road. And this rectangular pumpkin patch is in the northeast corner of this square plot of land. So this is a square in total here. The area of this pumpkin patch is 600 square meters. So this area inside is 600. The question is, what is the area of the entire plot of land based on these dimensions? The area of a rectangle is just its length times its width. So if we could figure out what the length and the width of this little rectangle are, we'd have an expression, and eventually we will have an expression that involves s's, and also that's equal to 600, because the area of this pumpkin patch is 600 square meters. I don't know exactly what the numbers are going to work out to be beforehand, but I do know that that this length of the field is 40 meters. And I know that the entire thing, since this is a square, the entire thing is the same as the side length opposite of it. So the entire length has got to be s. So if this whole thing is s, and this part of the field that leads right up to the pumpkin patch is 40, I think what this tells me is that this side has got to be the whole thing, take away that 40 meters. And for the same reasoning, I think that this whole side is also s, because this is a square and all sides are the same length. This whole thing's length is s, but from here, from the south corner all the way to the bottom edge of the pumpkin patch is 30. So that tells me that what's left over here is got to be the entire thing, take away those 30 meters. So I think the length of this pumpkin patch is s minus 30, the width is s minus 40, and the area of a rectangle is length times width. So I put that together, and I think an expression for the area of this pumpkin patch is s minus 30 times s minus 40, and that's equal to the area of the pumpkin patch, which is 600 square meters. This is an equation that if I could solve this equation, I would know what s is. And if you know what s is, then I could just multiply s times s and get the area of this whole square field. I can't just use exactly what we were doing before, in that I can't just take s minus 30 and set equal to 600, because there's plenty of combinations of ways to make these two things multiply together to be the answer 600. What there is much fewer of is ways to make this equal to 0. So I think what we're going to do, our strategy, is going to be to multiply this right side out. Then I can subtract 600 from both sides and get an equation that's equal to 0. And when I'm done with that, I'll try to solve that equation. So I'm going to multiply this out. I'm going to use FOIL here because I don't want to draw a big box, but you could draw a box if you want. I'm going to multiply this s to the s and the minus 40, and multiply this negative 30 to this s and this negative 40, and get this. S times s is s squared. S times minus 40 is minus 40s. Minus 30 times s is minus 30s. And minus 30 times minus 40 is plus 120, or 1, 2, and then there's 2 zeros at the end, so there'll be 2 zeros here. Or just use your calculator to multiply 30 and 40. You get 1200. And this is equal to 600. I can combine these like terms. And this is now a problem that looks just like the ones we were solving in the previous learning target. So to solve this, I can solve any equation like this, but using factoring, but I need to get it equal to 0. I don't want this to be a 600 here, so I'm going to subtract 600 to make this going to be 0. And I subtract 600 from 1200. Again, you can use your calculator or recognize that that's just 600. If I could factor this, then I'd be in a good spot. The numbers are relatively big, but they're not actually that hard to grapple with, I don't think. Let's see, if I want to factor this, I need to multiply the first and the last together. And the adding term is this middle term here. So I need a pair of numbers that multiplies to 600, but adds to negative 70. Well, there are lots and lots of numbers that multiply to 600, so maybe we start with some ones that are easy to see. The easiest one is 601, 601, but you can't add 601 together to get 70, so that's not going to work. I see that 600 ends in zeros, which means that 10s go into it. I know that what times 10 is 600 is 60. And hey, what do you know? 60 and 10, you could combine together to make 70 if both were negative. Negative 60 and negative 10. Minus 60 times minus 10, two minuses make a positive. 6 times 1 is 6, and 2 zeros is 600. Minus 60 minus another 10 is minus 70. You could use a box to factor this, or I'm going to, again, make use of the shortcut that we've seen, that I know that these are the two numbers. They're going to be in the parentheses along with an S and an S. So I think by my shortcut, I know that S squared minus 70s plus 600 is equal to S minus 60 times S minus 10. Again, if you are not sure, you want to check to make sure you did it correctly, you can always distribute this back out and make sure and check to see do you get what you started with. And the answer in this case is yes. So what does this tell me? What are the solutions to this equation? What I need to find s's that make either one of these two terms 0. I think those are going to be either an s that makes s minus 60 equal to 0, which is positive 60, or an s that makes s minus 10 equal to 0, which is positive 10. We have two possible solutions. We need to check to make sure that they make sense. One of these makes sense and one doesn't. It turns out that s equals 10 is not possible for this to be the length of this field. Why is that? Well, if s is 10, if this whole length is only 10 meters, how could this smaller part of it be 40? That's just simply not possible. The s has got to be bigger than 40, and it's also got to be bigger than 30, because 30 and 40 are smaller parts of this whole length. So s is too small. S is not valid, it's too small for this problem. 60, however, does work. 60 minus 40 is perfectly fine. That would make this length 20. 60 minus 30 would make this length 30. And that's perfectly fine for this pumpkin patch. So the value of s that solves this is 60, which means that the area of the field is 60 times 60, which is 3,600 square meters.